Alright, we continue with this paper, November 2015. We're dealing with question 3.2. So yesterday the last question was sketching our cubic graph and using Newton's method to find the x-intercepts. Okay. So here, another application of differentiation question. So, an open cardboard box. So we have a box which is open. So similar to this one. This is an open cardboard box. Okay. So an open cardboard box with this square base, but this one is not a square base. This one has a rectangular base. Okay. Is required to hold 108 cubic meters. That means that is the volume. Given, determine the dimensions that require the least amount of material and neglect the thickness of the material and waste in construction for 5 marks. Right, and we were given these two formulas. So, let's see what we're going to do. So let's go back to the question and look for all the given information, the key information. Number one is, it's open. Okay. So, just the box I just showed you now, it's an open box with a square base. Another bit of critical information here. It's a square base where you can see the base, the bottom, that means all sides are equal in the bottom, the base. Is required to hold 108 cubic meters. So what does that mean? It means my volume is equal to 108 cubic meters. Determine the dimensions. Right, that means determine the distance of the length of the sides and the heights that require the least. Right, so least is a key word there. So least will mean minimum. Okay, so least will be minimum. So when you see this word, you know it's associated with the first derivative. When you see minimum, least, or even maximum or most, you must know we are going to be differentiating. Right. So determine the least amount of material and neglect the thickness of the material and waste in construction. Okay. Now, well, this one here we don't even have to go and work out the formula, but you should be able to work this one out even if they do not give it to you. Right, the area. So if you want to work out the area, I'm talking about surface area. Right, surface area. This is a surface area formula. That means basically all the areas of the surfaces. So you just take a real box. So what do we want? We want the area of the bottom. The bottom here is x and x, which is a square. So x times x will be x squared. Right, so that's the area of the bottom. That's where they're getting this x squared from. Then what about the other surfaces? In the top, there is no surface here because it's an open box. But what about this area? There's one surface here, one there, and one there. So what is the area of this surface? So let's look at it. We need the length and the breadth to work out the area. So area is length times breadth. So it's x times h. Right. So xh is this area. That means xh will be this area, and this area, and the area in the all four areas here. Can you see that? It's just that this is not a square, but if it was a square, everything will be equal here. So you've got 4 xh's. Yes, that's where you get the 4 xh from. If it was a closed container or closed box, then you won't only have the bottom area, which is x squared, the top area will also be x squared. So therefore it will be 2x squared. Be careful. Read, is it open or is it closed? Alright. So we got that sorted out. Now, what do we do? Okay, so we're given volume is equal to 108 cubic meters. We want the minimum, the least amount of material. So we want to work out the minimum surface area. That's what we want to do. So that means we need to differentiate your A. Alright. So let's look at the formula for area, the surface area, which is 4xh plus x squared. So the variables here, x and h, can we reduce it to just one variable? We can. Right. Instead of having x and h, we want x only. Okay, so what do we know about volume? We were given volume. Volume is equal to x squared times h, area of base times perpendicular height. What is the value of v, which we were given? 108 is equal to x squared h, and now I can make the height subject of the formula. So it's going to be 108 divided by x squared is equal to h. Okay, now what do we do? Substitute into the surface area formula. So therefore, A is equal to 4x times h plus x squared. And what is h? It is 108 divided by x squared. Simplify it before you differentiate to make it simpler. So this x and x will cancel with x in the bottom, but we will take x to the top. 4 times 108 is going to be 432. X to the power negative 1. You're clear with that? And we got plus x squared. So that is the formula ready for differentiation. Alright, so what do? We now find dA, dx, you're differentiating with respect to x. So the derivative here, 432 times negative 1 will be minus 432. X minus 1 is minus 2 plus the derivative of x squared, which is 2x. Alright, so for a minimum area, dA over dx must equal to 0. It's like your turning points. For maximum or minimum turning point, first derivative equal to 0. You write this down. And now we substitute minus 432 x to the power minus 2 plus 2x equals to 0. And now it is a solve for x problem. Right, so now it's going to be minus 432 divided by x squared plus 2x is equal to 0. I need to solve for x. What do? I can multiply by x squared on both sides. So if I multiply by x squared, I'm left with minus 432, because x squared and x squared will cancel. 2x times x squared will be 2x to the power 3, and 0 times x squared is 0. Or if you wanted to, you could just take 2x to the right and cross multiply. You're going to come to the same thing. Right, so I'm going to take 432 to the right. So 2x cubed is equal to 432. So therefore, x to the power 3 is equal to 432 divided by 2. So x to the power 3 is equal to 216. So now that is x to the power 3. So I need to find the cube roots of both sides. Okay, because that's x to the power 3. So what is x equal to? X is equal to 6. So it's an easy one. Okay. So now x is equal to 6. So therefore, h is equal, what was h equal to? 108 divided by x squared which is equal to 108 divided by 6 squared, which is equal to 108 divided by 36, which is equal to 3. Okay, so the dimensions, so you can say therefore the dimensions are 6 meters and 3 meters. So this one is the height. 3 meters is the height. Okay, that was h. 6 meters would be the distance, the size of your base here. Alright, so that was our first application. Let's move on to the next one. Question 3.3. An electric current is varying through a resistor of 16 ohms. The rate of change of current is 0.6 amps per second when the current is 12 amps. Find the rate of change of power developed with the current at 12 amps. Okay, so let's go back. Let's look at the information given to us. An electric current is varying through a resistor of 16 ohms. So my R is equal to 16. The rate of change. Now when you see the word rate of change, okay, that means derivative. Okay, rate of change. That means derivative. So the rate of change of current is 0.6 amps per second. So that is not I, it is the derivative of I. Okay, I is current, but this is the derivative of current with respect to time because it's amps per second. See? So we're going to go di dt, the rate of change of current with respect to time, so which is 0.6 amperes per second when the current is 12 amps. So when your current is at 12 amps, the rate of change there is 0.6. Now find the rate of change of power. Find the rate of change of power developed when the current is 12 amps. And they give you the formula. So power is equal to I squared R. So what do we want to do here? We want to find the rate of change of power. So we are differentiating with respect to time here. This is implicit differentiation. Okay, so I'm going to go d over dt of both sides. I'm differentiating power with respect to time. That means I have to differentiate I squared R also with respect to time. Right, so we're going dp dt. Now, how many variables are you counting here? 2. Can you see that? And they are being multiplied by each other. So if 2 variables are being multiplied, we use the product rule. Okay, so this is going to be product rule. Right, so the product rule, so if you have y is equal to u times v, the product rule, first derivative y prime will be u v prime plus v u prime. Write down the first, differentiate the second, write down the second, differentiate the first. So my u is going to be I squared and my v is I. So the product rule goes, write down, copy the first, which is I squared. Differentiate the second. differentiate r. So it's going to be 1. But remember, we are differentiating with respect to time. This is implicit differentiation. So you're going to multiply by dr dt. Okay. Plus, write down the second term there, which is b, which is r. Differentiate the first. Differentiate I squared. The derivative of I squared is going to be 2i times di dt. So remember, if you're differentiating I, it's going to be multiplied by di over dt. If it's r, multiplied by dr over dt. Okay, this is implicit differentiation. Now, let's have a look at the substitution. So, I is 12. We know you're going to be substituting 12 there. So let me just go dp dt. So this is going to be I squared times 1 times dr over dt plus r times 2i times di over dt. So what is I? I is 12. So that is 12 squared times 1. Now, dr over dt. Okay, so your dr over dt, that means the rate of change of your resistance. Now, they did not tell you that there is any change in the resistance. Okay, so if there is no change, that means zero change. Understand that? No change means zero change. So the dr over dt will be 0 plus r. What is your r? 16. And then you got 2i. So that will be 2 times I. I is 12. 2 times 12 is 24. And then you got di over dt, which is 0.6. Work that out. What do we get? Calculator. So I'm getting 1152 divided by 5, which is equal to 230,4 watts per second. Because power is in watts. Okay. I got that 230,4. Because the first term there is straight to 0. Right, we move on to question 4, integration. Chapter 4 also in your textbook. Right, so here the question is determine the integral. This is a fraction by resolving the integral into partial fractions. Okay, now be careful. Don't go and factorize and rewrite it into fractions. You need to make sure first that the numerator is of a lower degree than the denominator. Only if the numerator is of a lower degree than the denominator, then you will use partial fractions. In this case, this is not a proper, this is an improper rational fraction because the numerator is of a higher degree than the denominator. How do I determine that? You look at the power. The highest power here is 4 and compare it to the highest power in the denominator, 2. So the top is larger than the bottom. So therefore, we will have to simplify first by using long division. Exactly. We will be using long division. Right, so long division. Right, so we've done long division. You can see my other videos for N6 too. I've done long division examples. So remember, the numerator is going to be called the dividend now. The denominator is now going to be called the divisor. Right, so the divisor, x squared plus x minus 2 on the outside, and the dividend on the inside here, which is 3x to the power 4 plus 3x cubed minus 5x squared plus x minus 1. So what are the rules? It's a 4-step process. Okay, I'm not going to go over the whole thing now, but I'm going to do it a bit quick. So first step number 1 is to make sure it's all in order, highest to lowest. That's a 4, 3, 2, 1, x to the power 0. That's a 2, 1, x to the power 0. Right. Then it's term 1 divided by term 1. We divide first. So 3x to the power 4 divided by x squared will be 3x squared. The next step is to multiply. So the answer that you just worked out, you will multiply it by all the terms of the divisor. Okay, not only term 1. So 3x squared times x squared will be 3x to the power 4. 3x squared times x will be plus 3x to the power 3. And then 3x squared times minus 2 is minus 6x squared. So that is divide, multiply, we've done, subtract. Okay, subtract. It's going to be top minus bottom. Top minus bottom, top minus bottom. The easy way to do it is change the sign of the bottom term and add the two. Okay. So at the moment it's a positive. If you change the sign, negative. Positive, change it to negative. Negative, change it to positive. And you add if you are doing the same. So therefore, 3 minus 3 will be 0. 3x to the power 4 minus 3x to the power 4. Term 1 when you subtract must always be 0. If you don't get 0, you made a mistake. You must always get a 0 when you're subtracting these first two here. Top minus bottom here, it happens to be a 0. 3 minus 3 again, that is also a 0 there. Then you got minus 5 plus 6, which is going to be a positive 1 x squared. So we're done with subtraction. Now the next step is bring down all remaining terms. If you don't bring down 1, you bring down everything one time. So that will be plus x minus 1. So this is the bring down part, the last step. Now we go back and check, is it possible to divide? Remember, this is now the dividend, this is always the divisor, and x squared can be divided by x squared. What is x squared divided by x squared? That's going to be 1. Then multiply, 1 times x squared is x squared. 1 times x is going to be x. 1 times minus 2 is minus 2. Now subtract. So when you are subtracting, change the sign of the bottom term. So this is a negative, it's a positive, negative, negative. It's a positive, negative, negative becomes positive. So now I got a negative 1 plus 2, which is a positive 1. Plus x minus x, 0. Plus x squared minus x squared, 0. Now, this is my dividend, which is smaller than x squared. This is x to the power 0, which is smaller than x squared. So this is the remainder. Now you can't divide anymore. This is your remainder. Alright, so how do we write this out? Okay, so therefore, what did we have? We had 3x to the power 4 plus 3x cubed minus 5x squared plus x minus 1 all over x squared plus x minus 2. And after using long division, we have 3x squared plus 1. And then, which is what you see your quotients there, plus you always will add the remainder over the original denominator, the remainder over the denominator. That's plus 1 over x squared plus x minus 2. How do you check if this is correct? You will take out your calculator and you will substitute a value for x into the original fraction, and then you will get an answer. You will take the same x value, substitute into the right hand side, and you must get the same result as what you had on the left hand side. Then you know that everything is correct. That's the fastest way to check in an exam situation. You got your calculator, few seconds, type it out, check if it's equal. The other way to check when you're at home, you've got time, you're obviously going to find the LCD here. If you find the LCD, you must get back to what it was originally. Right, now, where are the partial fractions? There's the fraction here. Can you see that? So this is where you're going to apply partial fractions. Right, this you will leave it out until you work out your partial fractions. At the end, you will integrate everything in one line. So let's apply the partial fractions now. So we got 1 divided by, you know that you must always try and factorize. The factors there are going to be x times x, which is x squared. Then we're going to have a plus 2 and minus 1. So that's going to be 2 minus 1, which is 1 minus 2. So the partial fractions now is going to be easy. You can see that. This is equal to a all over x minus 1 plus b all over x plus 2. And then now what we do is we multiply by x minus 1, x plus 2 on both sides, which I'm not going to show you. You know you've done many examples now. So if I multiply by x minus 1, x plus 2 on the left hand side, it's going to cancel. I'm going to end up with a 1. Remember, whatever I do on the left, I do on the right. So I'm multiplying by x minus 1, x plus 2 here. X minus 1 and x minus 1 will cancel. I just end up with x plus 2. Here I'm also multiplying by x minus 1, x plus 2. X plus 2 and x plus 2 cancel. So you end up with x minus 1. Now, we can use the method of substitution. There's two methods. The other method is called equating coefficients. Unnecessary. Use substitution, you get your answer in a few seconds. So what values can I use to substitute? Now, what am I doing now? I want to find out the value of A and B. So if I want to find the value of A, that means I'm going to eliminate B from this problem here. If I want to eliminate B, that means I want B to be multiplied by 0. Because 0 times B will be 0. So if I want to eliminate B, I need x minus 1 to equal to 0. So what value of x can I substitute here? Obviously it has to be 1, because 1 minus 1 will be 0. So there we go. Let x equal to 1. So on the left hand side, I have 1. On the right hand side, 1 plus 2 is 3 times A, which is 3A. And here, 1 minus 1 is 0 times anything is 0. So B has been eliminated. That's why we substituted x is equal to 1. So therefore, 1 over 3 is equal to A. Now, I want to go and work out the value of B. So I will eliminate A. If I want to eliminate A, I need 0 to be multiplied by A. So what value of x can I substitute that will result in x plus 2 becoming 0? Simple, minus 2. So let x equal to minus 2. So therefore, I have minus 2 plus 2, which is 0 times A, which is 0. Sorry, that is the right hand side. On the left hand side, I have 1. Right, I forgot mine. That's 1 is equal to 0. And here, remember, minus 2. Minus 2 minus 1 is minus 3. Minus 3 times B is minus 3B. So 1 over minus 3 is equal to B. Alright, so now we need to integrate everything. So therefore, we are going to integrate this whole thing here. Everything here. So let's go back to the one that we left out, which is 3x squared plus 1 plus 1 over this here, which is a over x minus 1, which is 1 over 3 over x minus 1 plus b over x plus 2, that is minus 1 over 3 over x plus 2. And now you integrate. So this is going to be 3x to the power 3 over 3 plus integrate 1, that is x. Integrate this one. So now remember 1 over 3 is a constant. If I can write it in front, here the derivative of x is 1. This is an exact derivative. Okay, which we're going to deal with in the next few questions. So I'm going to do this by inspection. Learn 1 over 3, learn absolute value of x minus 1. This is going to be minus 1 over 3. Learn absolute value of x plus 2 plus c. I didn't have to go and use any tricks here because the derivative of x is just a positive 1. Okay. So you can see 3 and 3 will cancel there. And that is your 5 marks. Right, now we move on to question 4.2. All your integration problems. They started off with partial fractions. Remember, for more partial fractions, long division, we can always check my N6 videos. Right, if you're not clear with long division. Now, here, this question. Determine the integral of y dx in each of the following cases, and you're given the question as y equal to. Right, so when this is the question paper, when you are answering this question, you will not write down y is equal to. Right, you must write down the integral of y dx. That means you're going to put your integration sign, and you will not write down y, you will write down what the value of y is. Okay, which is sine to the power 3 all divided by sec. Right, it's an integration problem. Okay? So you put in your integration sign. So remember that for tomorrow. Okay, so now we know what did we do in class. We did product when we're integrating powers of sine and cos. When you have sine is multiplied by the derivative of sine, which is cos. So in here, there's no cos, it's 1 divided by sec. But you should know your identities here. That you got sine cube x and 1 divided by sec is cos. 1 divided by sec is cos. So in this situation here, what do we have? We have the integral f of x to the power n f prime x dx. That's exactly what we have here. How do I know that? Because the derivative of sine is cos. You must have all the derivatives in your head. Don't waste your time with the formula sheet for differentiation. Right, that is the most important. You must know your differentiation, otherwise you will not know your integration. So, here f of x is sine and the derivative of f of x is cos. So by inspection, the answer will be k times f of x to the power n plus 1 over n plus 1 plus c. So this formula works only when n must not equal to negative 1. So that is your formula then. Right, if n was negative 1, then you'll be using limit. Okay, that's the second time. So in this situation, derivative of sine x is cos x squared. So the answer by inspection is going to be sine x to the power 4. F of x, n plus 1, 3 plus 1 is 4 over 4 plus c. If you wanted to use u substitution, then you can let u equal to sine x, and then you will see it will work out easily. Alright, that is u substitution. I'm going to use u substitution in the next one. So that's 4.2.1, and now 4.2.2. You got y is equal to x divided by 2x squared plus 3. This is the question paper. When you answer, you will put in your integration sign, the integral of x divided by 2x squared plus 3 dx. Okay. Now, here What do I notice? I notice that this is a fraction. Okay, and the numerator has the power 1 there. The denominator x squared, that means the numerator is a derivative of the denominator, because the derivative of x squared, forget about the constants, is going to be x to the power 1. Obviously, it's going to be 2x to the power 1, but the fact is we are focusing on the variable. So, this is type B. I call this one type A, this one is type B, where the numerator is an exact derivative of the denominator. If this is the case, then the answer by inspection is always going to be ln absolute value of the denominator plus c. So I'm using the method of inspection for this one. If you want to check U substitution, you can always check my other videos. 2020 we were doing U substitution. Is that now it will take too long to do U substitution? So watch inspection. So now this is how you do inspection. Right. So now what is the derivative? First of all, the denominator is f of x. The numerator is the derivative of the denominator. The derivative of 2x squared is what? 4x. So, there's supposed to be a 4 there in order for it to be an exact derivative. You clear with that? But there was no 4 there. There was just a 1. So, 1 is the same as 4 divided by 4. Clear with that? There's the 1 here. And what is what? 4 divided by 4. There's my 4, divide by 4. That's all. Once you understand this, integration becomes simple. So divide by 4 means multiply by 1 over 4. Right, so therefore, now it's perfect match. K is 1 over 4, so there's my 1 over 4. Natural log or ln, absolute value of the denominator, plus c, and you're done. That is inspection. Okay, it's up to you. If you want to use U substitution, then you will let U equal to the denominator. Alright, next one. So we got e to the power arctan of 1 plus x squared dx. Now, looks like they're going type A, type B, type C in order of how it's done in the book there. You can see you got one of each type there. So now, this one where you see E, straight away, this is type C. So when you see an E, that means we are now dealing with something like this. K e to the power f of x times f prime x dx. And if this is the situation, the answer is just going to be k e to the power f of x plus c by inspection. Okay. Now, the integral of e to the power inverse tan arctan, that means tan with a negative 1, same thing, divided by 1 plus x squared dx. Now let's see what's happening here. So we got inverse tan. So we're checking now. F of x is inverse tan. So your inverse trig function, if y is equal to inverse tan of f of x, your differentiation very important here. And dy over dx, the derivative is going to be f prime x all divided by 1 plus f of x all squared. It's on your formula sheet. But now, let's see. So, where's my inverse tan? There's my inverse tan. So, this is going to be the integral of e to the power inverse tan x times, let's write down, what is the derivative of inverse tan x? It's going to be f prime x. So my f of x is x. So f prime x must be 1 divided by 1 plus f of x. So that's 1 plus x all squared. Can you see that? I'm finding the derivative of inverse 10. And now I'm comparing it with the one that's given to me. And what do you notice? It's the same thing. What do you notice now? E to the power f of x, e to the power f of x times f prime x. By inspection, the answer will just be e to the power inverse 10 plus c. And you're done. That's it. Okay, that is by inspection. Right, the next example here is 4.2.4. Oh, I think I need more space for this one here. So, all right, 4.2.4. We have a fraction, and the numerator is not of a lower degree than your denominator. Okay, so we can use long division. Right, there's also another way to do it, but let me start with long division first. Alright, first of all, let's put in our integration. That's the integral of x squared divided by 3x minus 2. So it's a fraction, it does not satisfy the condition of f prime x over f of x. So then you can't just go and put linear because it does not satisfy that condition. So we will use long division. So your divisor is 3x minus 2 and the dividend is x squared plus 0x plus 0. Don't just write x squared here. Include plus 0x plus 0. It must be in the form ax squared plus bx plus c. Alright. Now you divide x squared divided by 3x. What are you going to get? Remember, you're doing x squared divided by 3x. So x will cancel with x on the top, so you're going to end up with x over 3. You're clear with that? Multiply now. X over 3 times 3x is going to be x squared. X over 3 times minus 2 is going to be minus 2 over 3x. You're clear with that? That's multiplication. Now, subtract. When you are subtracting, change the sign of the bottom term. So that will be a plus, that will be a minus. And then top minus bottom, you know, first term must be a 0. Top, right, so here 0 plus that will be a positive 2 over 3. X, bring down. So that was subtraction. The last step is bring down. There's nothing there, but I'm just writing down 0. Then you check again, is it possible to divide? Yes, because that's an x and that's an x. So what am I dividing now? I've got 2 over 3x divided by 3x. So x and x will cancel then. You end up with plus 2 over 9. And then you're going to multiply 2 over 9 times 3x and you're going to get the same 2 over 3x. These two must always be the same when you're using long division. Multiply also 2 over 9 times minus 2 is minus 4 over 9. Okay. Subtract. Change the sign of the bottom term and add. So this is a negative, make it a positive. This is a positive, make it negative. 0 plus 4 over 9 is 4 over 9. That plus that, or that minus that, 2 over 3x minus 2 over 3x is 0. So now you cannot divide anymore because the dividend is x to the power 0, which is smaller than x to the power 1. So now let's write out our solution. So therefore, x squared over 3x minus 2 is the same as x over 3 plus 2 over 9 plus the remainder all over the divisor 3x minus 2. Alright, now what do we need to do? We need to integrate everything. So let's write it down. So I need to integrate. So the integral of x squared divided by 3x minus 2 dx is equal to the integral of x over 3 dx plus the integral of 2 over 9 dx plus the integral of 4 over 9, and that's 1 over 3x minus 2. Notice what did I do to the 4 over 9? I wrote it in front of your integration because now I have a fraction, and this here is type B, where the numerator is f prime x and the denominator is f of x. So the answer is going to be k ln absolute value of the denominator plus c. But let's check, do we have an exact derivative? Okay, remember I'm using inspection here. So f of x is 3x minus 2 then. F prime x, the exact derivative of 3x is supposed to be 3. Alright, well, let me just do that in the next step. Sorry, let me just do that in the next step so you see exactly what is happening. So that's plus 4 over 9. You got your 1 there. 3x minus 2. I don't want to interfere with this. So you must understand that there is a 1 here. But the exact derivative of 3x is supposed to be 3. But right, the exact derivative of 3x is supposed to be 3, but what it is a 1, and 1 is the same as 3 over 3. So if I got my 3 on the top, I must have 3 in the bottom. Can you see that? That means I'm multiplying by 1 over 3, and that is inspection. So we'll come to this now, but let's just do it, sorry, while we are at it. So now, what does this become? 4 over 9 times 3, which is 27, and that becomes 3 all over 3x minus 2. Now it satisfies this condition 100% because your constant k is here, f prime x is 3, f of x is 3x minus 2, so the answer is going to be 4 over 27 ln absolute value of 3x minus 2, and let's not forget about these two here. Integrate this one, it's going to be x squared over 2 times 3, which is 6, plus integrate 2 over 9, that's going to be 2 over 9x. And that is it, that is our 4 marks for this one. I'm going to use the other technique now. Right, so that is your 4 marks. This is the method of inspection. Right, for those of you who are using inspection, if you want to do U substitution, you must check my other exam papers where I do it using U substitution. Right, so the previous, the same example, we did it using long division. Now, what happens if you decide to use a U substitution? So if you're using a U substitution here, what you're going to do is you will let u equal to 3x minus 2. Okay, you let u equal to 3x minus 2. So therefore, du over dx, the derivative there is 3. And then you make dx the subject of the formula, which is du over 3. Okay, so therefore, I'm going to replace 3x minus 2 with u. So this is going to be u. I need a replacement for x squared. I already have a replacement for dx. I need a replacement for x squared. So I will go back. Remember that u was equal to 3x minus 2. So therefore u plus 2 is equal to 3x. Can you see that? So now u plus 2 over 3 is equal to x. So now I want x squared. So therefore, u plus 2 over 3 is equal to x, but I want x squared. So therefore, I will square x, and if I square the right hand side, I have to square the left hand side. So therefore, this will be u squared plus 4u plus 4, all divided by 3 squared, which is 9 is equal to x squared. And now I have my replacement for x squared. So this is going to equal to now u squared plus 4u plus 4 all over 9 divided by 3x minus 2, which is u. 3x minus 2 is u. And dx, there's my dx here, which is going to be du divided by 3. Okay, so now simplification. So what's happening here now is that if I invert and multiply here, if I check, remember this is u over 1. So if I invert and multiply, it becomes 1 over u. Okay, so basically this becomes 1 over u. This is 1 over 3 times 1 over 9, which is going to be 1 over 27. Okay, and this is going to be u squared plus 4u plus 4, all divided by u, but I'm going to separate it into 4 fractions. Okay, all divided by u, but I need to divide each one individually so I can cancel them. So this is going to be 1 over 27. U squared divided by u is u. 4 u and u cancel, that's 4. And this is 4 times 1 over u du. Okay, if it's divided by u, write it as 1 over u. Okay, always. Now we can integrate. It's all ready for integration. So I've got my 1 over 27 there. Integrate with respect to u. So this is going to be u squared over 2 plus integrate 4 will be 4u. Integrate 4 times 1 over u. When you integrate 1 over u, it's ln absolute value of u plus c. When you're done, substitute back for u. So this is equal to 1 over 27, and this becomes 1 over 2 u squared plus 4 times u plus 4 ln absolute value of u plus c. What was u? U was 3x minus 2. So that is my 3x minus 2 there. 3x minus 2. 3x minus 2. And your answer, you can leave it like this, it's fine. It doesn't look like the other one, but if you have to remove the square this whole thing, remove all the brackets there, every term there will match with what we have, except the constant. You might have just a constant term there, okay, which you don't have to worry about. If you have values, like if integrating maybe from 0.2 to 0.3 or whatever, you can check it out and then you do the same there, you'll get the same answer. Right, so this was using u substitution. So that was this problem, and then we have 4.3. Let's finish 4.3 before we deal with the other one. So 4.3 is determine the integral of 2x times e to the power 2x. Right, so here, what type of problem is this? It's multiplication, but you have e here. Check your power. Remember, we just did type C. If this is f of x, is this f prime x? If this is 2x, is the derivative of 2x? No, it does not satisfy a type C condition. So if it's multiplication and there is no exact derivative, then it's going to be integration by parts. Okay, so this is integration by parts. Let's write it down. Integration by parts. Right, so integration by parts, the formula is the integral of f of x times g prime x is equal to f of x times g of x minus the integral of g of x times f prime x dx. Alright, so in integration by parts, you go to your priority list. Right, and in your priority list, you start checking what number is 2x on the priority list, what number is e to the power 2x. So 2x is number 3. That priority list must be in your head. Right, 2x is number 3, power exponential is number 4. So therefore, f of x must equal to 2x. So if f of x is 2x, that means f prime x is going to be 2. So g prime x will be e to the power 2x. So g of x will be the integral of e to the power 2x, which is going to be e to the power 2x all over 2. So now, f of x is 2x, you can see there. How do I know f of x is 2x? That's from the priority list, not because you see 2x written down first there. Okay, that is not a reason for choosing f of x as 2x. The reason is the priority list. And you can always check other videos on integration by parts or N6, and then you will see in detail. So now, this is equal to f of x, which is 2x, g of x, which is e to the power 2x over 2, minus the integral of g of x, which is e to the power 2x over 2, and f prime x is 2. Now let's simplify and work it out. 2 and 2 cancel, that's x e to the power 2x minus the integral of e to the power 2x. Because this 2 and 2 also cancel. Can you see that? So therefore, this is x e to the power 2x minus e to the power 2x all over 2 plus c. And you're done. That is your integration by parts, which was 4 marks. This was 4 marks. And now we move on to the area and volume question. Right, question 5. So we're given the sketch. The sketch shows the area bounded by the curve. I'm reading the question. X is equal to 4 over y. X is equal to y squared. And the line y is equal to half. So this is the question paper. So this is how it is given to us. So we've got 3 different graphs. They're intersecting. We're given a point of intersection here. 2,52, 1,59. That's x, that's the y value. And 5.1.1 for how many marks? Prove that the point of intersection of the 2 curves is equal to that, which is 3 marks. Alright, so now, points of intersection, how do we work that out? So there's a point of intersection. So now, you know for points of intersection, what do you do with the 2 equations? You solve simultaneously. So what you're going to do is solve simultaneous equations. So which 2 curves are touching them? Which 2 curves are intersecting? So it's this curve here. what do we have? We have x is equal to 4 over y, and this curve here, x is equal to y squared. So now, it's up to you. X is equal to 4 over y is already the subject of the formula here. So let me just substitute into equation 2. So that means 4 over y is equal to y squared. So now, get rid of the fraction, multiply by y on both sides. So therefore, 4 is going to equal to y to the power 3. So now, I need to work out the value of y. So therefore, if it's a cube, I'm going to find the cube roots. So y is equal to the cube roots of 4. Give me your calculator there. So the cube root of 4 is equal to 1, 5, 8, 7, 4, 0, 1, 0, 5, 2. That is my y value. Alright, so now I need to work out the corresponding x value. Remember, x is equal to 4 over y. So that's going to be 4 divided by 1, 5, 8, 7, 4, 0, 1, 0, 5, 2. Then we get 2, 5, 1, 9, 8, 4, 2, 1. It's important to have all decimal places first before you round off, because for checking your solutions, you can't use the rounded off values, okay? But anyway, you must see as many decimal places as possible. So this is 2, 5, 2, and this one is 1, 5, 9. If we round it, here we are rounding off to only 2 decimal places to show that that is true. So there's it there, there's it there. So that is your simple 3 marks there. That is, you just found the value for x and y. There's it. 2, 5, 2, 1, 5, 9. Right, so next question. Calculate the area of the bounded region. That means the area bounded by all 3 curves, which is this area here. Okay, now we have a choice now to use a representative element with a breadth of delta y or with a breadth of delta x. Which one will be best in this situation? It will be using a breadth of delta y. Okay, but we will do both just to make sure that you know what's happening here. So, if I go here, there's my delta y. So, I'm using a breadth of delta y. That means the length is the longer side, which is from there to there. So, what do? You check the 2 end points. Right, so this is a critical point, that's a critical point. Can you see that? Right, so this is the difference between y, delta y. So this is the difference between x. Let's call this one x1. Let's call this x2. Right, there are 2 different x values there. Right, so now what's touching here is x1. What's touching this side is x2. Very important. Go back to the sketch. Now why am I saying the best option is delta is using this type of rectangle? It's because if you check on the right and the left, from the top to the bottom, what's touching on the right will always be x1, what's touching on the left will always be x2. Even if I go and up or down, it will always be x2. Right, so now you're going to write down delta A, which is area of the representative rectangle, which is length times breadth. Right, so what do we have? We have, here's the rectangle. Right, so you know this is the breadth, which is delta y, and this is your x1, that's x2. So therefore, the length is the difference between these two values here, the change in x, which is going to be x1 minus x2. So your length is x1 minus x2 multiplied by your breadth there, which is delta y. This is delta a. This is a compulsory step which you must write down. Okay, this is the area of the representative rectangle, and now you will write down the formula for total area. Once you write down total area, you just write down A, and now your delta y becomes dy, and then you have x1 minus x2. We are integrating with respect to y, so therefore we need the y values there, d and c. So we need the y values at the points of intersection. In other words, at the beginning and at the end of the area. So, the area, there's your area here. This is your area. This is how it looks. Here's it there. Okay, it looks something like this here. So, you have a point there and a point there. So, what am I saying? That here's your representative rectangle. Okay, so if we are integrating with respect to y, that means we need to know the highest point and the lowest point. Okay, so the highest point here is this point, and if you move down, if the lowest point is this y value, interested in the y values only. Right, so we know that this is, what was it, 2,52 and 2,59. So that's 2,52, 1,59, and this value here, we are not interested in the x value, we are only interested in the y value for this. What is the y value here? The y value there is up. Okay, you're clear with that? So therefore, this is going to be 1,59, and this is going to be 1/2. What is x1? x1 in terms of y, x1 is 4/y, so there's my 4/y here. Minus x2, x2 is y squared, you can see that. My x2 is y squared. So I'm going to integrate this, that will be, remember 4/y is the same as the integral of 4 times 1/y dy. You're clear with that? 4/y means 4 times 1/y. So when you integrate 1/y into the absolute value of y, integrate minus y squared, that's minus y to the power 3/3. Substituting my 1,59. I want to use the full value here, which is 1,587,401,052. Okay, and the bottom value is just 1/2 there. Let me that calculator there. That one's it. Right. So that's going to be 4 ln of y minus 1/3 y to the power 3. That's it. What are we substituting? 1,587,401,052. So when we do our first substitution, remember what are you doing? You're going to substitute this into your variable y there. And what do we get now? When we substitute the first upper limit there, we get 0,515,059,1482. Subtract, substitute the lower limits. which is 0, comma 5, and then you get minus 2, comma 8, 1, 4, 2, 5, 5, 3, 8, 9. Right, so that's 0, comma 5, 1, 5, 0, 5, 9, 1, 4, 8, 2, plus 2, comma 8, 1, 4, 2, 5, 5, 3, 8, 9, and the area 3, comma 3, 2, 9, 3, 1, 4, 5, 3, 7 units squared. That is the area. So therefore it's 3, comma 3, 2, 9 rounded off to 3 decimal places. Okay. Right, I'm still using this calculator. Right, so now that's one way of dealing with it, using a representative rectangle of delta y. Now, what happens if you use a representative rectangle of delta x? Let's see how this is going to work. Right. What happens if you decided now to do this? You got your area. So there's my area. Let me redraw the area which is going there, there, and coming something like this. So there's your area again. Okay, I'm just enlarging what we have there. Now, if we use a representative rectangle of delta x, so here's my delta, with a breadth of delta x, so let me draw my representative rectangle there. So there's my rectangle. Can you see that? There's a rectangle. Now, let's, with a breadth of delta x here. So now, let's check what's touching the top end, what's touching the bottom end. So, I got the top, what's touching there and there. So let's go to the graph. Okay, so this graph here is this one here. There's the shape. Can you see that? This graph is this one. So we're calling this, okay, it's gonna, if it's x2, we call it y2. So this is going to be y2. What's touching the bottom here? This is the straight line here. What did we call? We didn't label the straight line. Let's call the straight line y3. We didn't use it in our calculation, in our integration. You can see that. So this is y3. Now, what happens when I move the rectangle? If I take this rectangle and I draw it here, because remember the whole thing is the area, not only the small part here, the entire bounded region. So if I draw my rectangle here, let's check what's touching the top end and then the bottom end. So the top end here is here now. You see that it's this graph, which is y1. And the bottom is y3. So there's a cutoff region here. Can you see this point here? Is where things change. Can you see things change at that point there? From here to here, it's y2 and y3, top, bottom. As soon as you pass this region, this cutoff, this point of intersection, then it's no more y2 on the top, it's now y1. So there are two areas here. Let's call this area P and area Q. You can call it whatever you want to. Area 1, area 2. So let's deal with area P. So for area P, delta A is equal to length times breadth. Your length for area P is going to be y2 minus y3, because the length is the longer side. Can you see that? Top minus bottom, and your breadth is delta x. So now, if I want to work out total area for area P, I'm going to integrate using the x values there. Y2 minus y3. What are the x values? What are the x values here? We need to find those x values. Right. So, we need to find out this x value. Which ones are we interested in? We are interested in the x value at this point, and the end is this point here, from there to there. Can you see that? From here to here. Because it's x, this is the beginning, this is the end. We know the end. We know this x value here. What is this x value here? It's 2, 5, 2. It's 2, what is it? Where did we write this one? Oh, I erased it. Okay, let's work out the proper value there. I want the full answer on the calculator. What did we work out there? I just erased it from the board. Yeah, read it out for me. 2, 421. Okay, so that is the upper limit. Now, the lower limit is this point here. There's it here. This point here. So I need to know what is the x value at this point. So this is a point of intersection of which two graphs? Y3 and Y2. Okay. So now, here, I know the y value at this point here. I know the y value there is half. You're clear with that? So all I have to do is take this half, substitute it into this equation to find the corresponding x value there. You're clear with that? Right, so it's where these two graphs intersect. So I know that x is equal to y2 all squared. Okay, so therefore x is equal to, what is that y2? It's 1 over 2 squared, which is going to equal to 1 over 4. You're clear with that? So there's my 1 over 4 there. What is y2? Okay, what is y2? Now, remember that y2 squared is equal to x. So this is not y2 squared, it is just y2. So I must make y2 the subject of the formula. y2's, if I find the square root of both sides, it's going to be plus or minus the square root of x. You're clear with that? Find the square root of both sides. However, we are dealing with only the positive because it's above the x-axis. So therefore, y2 is equal to just square root x. Okay, so that would be square root x minus what is y3? y3 is just half. Can you see that? y3 is half there. And then we're going to integrate and we're going to work this one out. Alright, now what about, we'll come back to this. I'm just setting up first. What about area Q? For area Q, delta A is equal to length times breadth. You know your breadth is delta x. What is the length for area Q? This area here, top is y1, bottom is y3. So that's going to be y1 minus y3. So then total area, you're going to integrate B and A, y1 minus y3 with respect to x. So now, your area is going to equal to, what's my B and A? Now let's go back to the diagram. So it's this point here, and this point here. There's the check. This point and that point there. Okay, so now what do we already know? We already know this point here, the lower limit, which is 2,52 or 2,519. But we do, what is this point here? Do we know this point? We know that y is equal to half there. What is x then? So all I do is, if I know that y is equal to half, I need to find x, substitute y equal to half into this curve here. Can you see this curve here? X is equal to 4 over y. Right. So I know that x is going to be equal to 4 over y is equal to half, which is equal to 8. So there's my 8 here. What is y1? Where is y1? y1 is going to equal to 4 over x. There's y1 here. Make y1 the subject of the formula. It's going to be 4 over x minus y3. What is y3? y3 is just half. Okay, so we set up our two problems. Now let's integrate. So integrate square root x. That's going to be half plus 1 is 3 over 2. 3 over 2 minus integrate minus half. That's minus half x. And then we need to substitute our 2,5198 and our 1 over 4. And let's see what we get now. Okay. So I'm just going to go for the final answer here. Right. Straight. Let's do, so what do we have there? The final answer. Obviously, you must substitute 2,5198 minus substitute 1 over 4. I'm just going to do it in one step. 2,5198,421. And our bottom limit is 1 over 4. We are integrating the square root of x minus half. Alright, so double check me here. I got 1, 4, 4, 8, 4, 1, 2, 2, 8, 4. That is for area P. Okay, now we need to work out area Q. So let's not mix this whole thing up here. This is for area P. For area Q, we integrate 4 over x. What do we get? We get 4 ln absolute value of x. Integrate minus 1 over 2. That's minus 1 over 2x. What are we substituting? We are substituting 8 and 2,519. So there's my 8, there's my 2,519. So I'm going to do it in one step again. Obviously, you need to substitute 8 first, put a minus sign, and then substitute the lower limits. Let's see what we get here for this one. So that's an 8, and that's 2,5198421. So that's 4 ln. Okay, so what am I getting here for this one? I'm getting 1,880,9,022,53 units squared. So area Q is this, area P is that. So therefore, what do we need to do? We need to add the two up because we split the area into two. So we work out the sum of both and let's see what happens. So we add there plus 1, 4, 1, 4, 4, 8, 4, 1, 2, 2, 8, 4, 3,329. Perfect. You can see that. If you add these two up, you get the same thing. So add area P plus Q and you get the same answer 3,329,314 exactly to the last decimal place. You can see that. That's why I don't round off. You must never round off when you are, if you want to check and compare if your answer is correct. Right, only in the final answer you can round off. So this was area. So why did I do this? To show you the different options that you have. In a situation like this, you do not want to split up, because splitting up the area, you end up doing extra work. You come to the same answer, okay, but it's good for your understanding, okay. Most of you won't even attempt this here. Very few people will actually attempt to split up the area. So the option is, you must know, understand the diagram and try to choose a representative rectangle where you don't split up the area like here. This is just one area. There's a chair. One area, one time gets you to 3,329. Using delta x for this example, you end up with two areas. If you add them up, then only you get to the answer. And then let's do the last one here quickly, which is the volume question. Alright, 5.1.3 is the volume question. Right, so calculate the volume generated when the area in question 5.1.1 rotates about the y-axis. Okay, so 99% of the time, if you want to know which is the best representative rectangle, or which is the easier one to choose, you go straight to the volume question, and if the question states rotates about the y-axis, then use delta y. Just like how we use delta y. So delta y was the easier option. So, because there's only one area, so therefore one volume. If we choose delta x, that means we're going to work out two volumes, just like how we worked out two areas, and then add it up. It's going to take too long. It's fine, but it will take too long. So we will stick with, if it rotates about the y-axis, then we are using delta y. Sorry, my mistake. In N5 level, you will not be able to use the other method, which is the disk method. So if the question states rotates about the y-axis, you must use delta y. You don't have a choice here. Only in N6 you can use one. You can use the other option. Okay. If the question states rotates about the x-axis, then you will use the breadth of rectangle with delta x. Alright, so that's just a tip there. So to save you time, too much of thinking in the exam, you must know exactly what to do. Alright, so remember the area formula, we are dealing with volume. What was this here? And what was that? Let me just refer to our diagram. We call that x1 and x2. So this was x1, this was x2. So now volume delta v y, because we are rotating about the y-axis. So we know delta y is perpendicular to the y-axis. Okay, so there's the y-axis here. Let me just see how it's. Yeah, so there's the y-axis here. And what do I mean by perpendicular? I mean that if you take this representative rectangle and you merge it with the y-axis, it's going to be a perpendicular situation. Alright, perpendicular means if they will intersect, they will form an angle of 90 degrees. Right, that's what perpendicular means. So, if delta y is perpendicular to the y-axis, then we are using the disk method. Alright, the other method is called the shell method. that is not in M5. Right, so with this method, volume is equal to pi r squared h, area of base times perpendicular heights. So in this case, it's going to be just like we had top minus bottom there, x1 minus x2. It's going to be volume of the top, which is going to be pi x1 squared delta y, subtract volume of the bottom, pi x2 squared delta y. Okay, where h is the height, h is delta y. Right, r, the radius, is in terms of x. The radius is in terms of x. So where I'm going r squared, it's going to be x1 squared first, subtract x2 squared. Alright, so now we take out a common factor of pi and delta y there. So I got x1 squared minus x2 squared. That's my delta Vy. So this is a compulsory step. And now total volume. Right, so that is our formula for volume. You can always go to your formula sheet, but there's only one formula here in N5. It's going to be pi r squared h. You must know what's your r and what's your h up here. Okay, so if we're using delta x, then h is going to be delta x. And it's going to be pi y squared delta x. Here it's pi x squared delta y. Right, so now let's do the substitution. So my Vy is equal to pi. What's my D and C? Same D and C there. The Y value there is 1,59. And the Y value in the bottom is half. What is X1? Where was my X1? What is X1? My X1 is, where's X1? X1 is 4 over Y, correct? So that's going to be 4 over Y squared minus my x2. What was my x2? It was y squared. All squared dy. Okay, remember this was the equation here of the hyperbola, and this one was the equation of the parabola. You can always check your diagram. Simplify first. That's going to be pi 1,59, 1 over 2, and this is going to be 4 squared, which is 16 divided by y squared, but you cannot have y squared in the bottom. You take it to the top, it becomes y to the power minus 2. Here, this is y to the power 4, and now we can integrate, so that will be 16 y minus 2 plus 1 is minus 1 over minus 1, 4 plus 1, that will be 5 over 5, substituting my 1,59 and 1 over 2. Let's see what we get here. Alright, so I'm substituting 1,59 first, and I get minus 12,09, 532,318. Substituting 1 over 2, and we get minus 5,121 over 160. end up with 19,9109 there. And then you multiply by pi, which will give you 62,552 units to the power 3. And that was the volume question. Let me just make sure and double check. Anyone already checked this one out? Worked it out? Correct. Okay. Now I'm saying, did you do this beforehand? Okay, let me double check this using the integration function on the calculator. So we get 1,59 on the top, 0.5 in the bottom. Then we are integrating there. And we got minus to the power 4. So yeah, let's substitute there. Yes, that is correct. Times pi. That's fine. The answer is correct. Right, unfortunately, that's all we have time for. But this is the main part of the paper. Okay, then there's just a few things left there which you can work out. Right, so make sure you practice.